Okay. Today I want to like talk about data definitions and data. Well, I'll call them DD blocks. Okay, just for short. And I will. I'm sorry. I'm-
It's a little disturbing looking at myself here.
why don't I like make it smaller so that it won't get into the way? Okay. So first, I want to talk about data definition, and I will move on to fully qualified identifiers, what I call FQI, and I want to like talk about the significance of using SQI, and then we'll move on to data definition blocks. If we have time, I want to talk about phantom nodes. I want to talk about like how to replace the entire structured data of a block, and we will also look at like how to handle nodes. For example, how to like create nodes, remove nodes, swap the data, and so on. Um, and if we want to, we can also get into the 15 types of fields that you can use inside a data definition, and then like the instances of those 15 types of fields. Well, 15 types of nodes. So we will also like, look at multiple nodes, multiple fields, and so on. So we have a lot of topics to cover. As I was like talking to Eric Espana, it also depends on like how much time we want to dwell on to like on certain topics. We may need another like hangout to like pick up whatever we cannot finish and we need to like pick up again. So let us talk about data definition for a moment, okay? And then we will look at data definition blocks. So let us look at some simple data definition, and I want to like highlight something while we are looking at them. First, I think Eric Gawker knows about this, and probably Chris too. When we look at a data definition, okay, let me just put up something simple. Well, probably cascade them in. So we are looking at simple text. Okay, why don't we try this one? Oh, it's too simple. Multiple text then. Multiple simple text. Okay. Still, I want to see more than this. Let's see, there are too many of them. Okay, it doesn't matter. Just like look at this one. Okay, the first thing we need to know, okay, is this. When we define a data definition, try to introduce groups and then put fields, okay, into groups, okay. This is my like normal way of doing things, but now I'm just like, okay, doing some demo and like putting up some simple data definition so that we don't see groups here just yet, okay. Now, the first thing we need to know is this. When we define, for example, two siblings, okay, in a data definition, we must like pay attention to identifiers. So for example, okay, here we have like the first text field, okay, with the ID text. If we do something like this, okay, we need to like observe a rule in data definition. Namely, all siblings must have unique identifiers. Okay, so I assume you know that. So this will not be well formed because we have two text fields, okay, having the same identifier. If we try to like submit this, okay, we can't because text, okay, the identifier text is used twice. Okay, so we have to do something like one or two or rename this to something else. Okay, that's the first thing we need to know. But I want to emphasize one thing. A moment ago, I said, okay, identifiers of siblings must be unique. I'm talking about siblings, okay? So if let's say two nodes, okay, or I'm sorry, two fields, okay, which are not siblings, then you can have the same identifier. It's very easy to prove, okay? Let me put up another one just to, well, one with like groups and so on. Let's say, so let's try this one. Okay. So we have a group called group. Okay, well, these are just like for demo purposes, so they don't have like I didn't really like care about like how to name them. So let's say okay, I have a group two here. So this group and this group are siblings, so they must have unique identifiers. Okay, but this text and this text, they are not siblings. Okay, because they don't have the same parent. So by what I said a moment ago, we should be able to submit this data definition, and Cascade doesn't care. Okay, so I'm just saying this. Okay, within the data definition, you can have identical identifiers everywhere. Of course, I mean, why you want to do why you want to do that, I don't know. But I'm just saying this is possible. So you can have the same identifier appearing everywhere, as long as they are not identifiers of siblings. Okay, is that clear what I'm trying to get at?
Yeah, I'm trying to think if I would ever want to do something like that, just out of, for whatever reason. But I don't think I've ever done that.
Well, one reason, okay. Let's say you want to like name your identifiers like after functions, for example. So you can have a chooser, okay, for image. You can have a chooser for page. Well, accidentally you call it page, you call it image, or something like that. You might have like the same identifier in different nodes, well, in different fields, okay, under different groups. You might come up with something like that. I don't know, okay? I'm just saying it could happen.
Fair enough. Fair enough.
Okay. So let me repeat, okay?
Eric, sorry, wait, can I interrupt?
Oh, go ahead. Go ahead.
If you have like one way I think of is if you have like a common attribute that you need to kind of loop over multiple times, like slideshow images, let's say.
Yep.
You can make the identifier the same. So if you have multiple entities inside a group, you can flag one as being this is the image, this is the caption, and then when you loop through, you could say if is image, grab that image. If is text, grab the caption.
That's a good point. Yeah, I can see that.
Sorry, Ming.
Yep. Okay. Thank you. So it won't hurt, okay? Well, it's possible, okay, to have like identical identifiers in different fields, okay? So that's one reason why we cannot rely on identifiers to identify nodes when we work with like DD blocks and pages, because identifiers are not absolutely, okay, in the absolute sense, okay, they are not unique, okay? They're unique only among siblings, but not in a data definition or in a page or in a DD block. Okay, that's the first thing we need to know. Okay, second thing, when we have something like this, okay, I'm going to change the code, okay? So let's say we have something. So I'm removing the group element and just keeping the text, okay? So we can have something like this. So let me call this text 1, this is text 2, and let's have a text 3, okay? Well, because they are siblings, so the identifiers must be unique, okay? So this is okay. Now, let me further, okay, put something, okay, like this, okay, multiple true, okay? And I want to turn the third one into multiple as well. Okay, so we'll have something like this. The first one and the third one are multiple, okay, but the second one is not. Okay.
Right.
Now, when we like associate this data definition with a block, then what happens? I mean, when you like deal with that block using web services, what happens? Well, something interesting. When you like, for example, okay, instantiate this field, okay, into nodes, okay. Now I want to draw a distinction between field and node, okay. When we deal with data definitions, we talk about fields, okay. So this is one field, this is a second field, and so on. But a field like this one, okay, this multiple field can be instantiated into multiple instances. So each instance is a node. And we can talk about like a set of nodes, which are instantiations of the same field.
Okay.
Okay, does it make sense?
Yes.
Okay. Now, when we look at web services, okay, this data definition, when associated with a DD block, okay, the DD block will have a flat array storing these nodes. So let's say the first, okay, field has 3 instances. Okay, so we have like 3 instances of text1. And then, of course, okay, text2, okay, can have only 1 instance. So if we look at the flat array storing these nodes, index 0, index 1, index 2 will be storing 3 instances from text1. Okay? Index 3 will store, meaning the 4th element, okay, will store the instance of text2. And then let's say we have like 3 more instances of this field, okay? So we have like 3, 4, 5, 6, okay? So index 4, index 5, index 6 will be used, okay, to store the 3 instances of text3. Do you follow?
Yes.
Okay. Now, what do you need to do to find the first instance of text3? What do you need to do?
I'm guessing you need to count how many values are in text1.
Exactly. You need to do something like that. So you need to first, okay, determine how many instances there are in text1, and then you know, okay, text2 will be right after that, and then the first node of text3 will be right after text2.
Right,
Okay?
because it's not multiple.
Yep. So it changes, okay, depending on how many instances you have, okay, in text1 and how many instances in text3. For example, if I'm to ask you, okay, how do you identify the last node of text3? Whoa, it depends. Okay. Of course, I mean, if you have a flat array, you look at the last one. But if, okay, you need to like loop through everything, okay, let's say you need to loop through all the nodes, okay, related to text3. Where to start, where to stop, you are on your own. And I mean, you cannot really hard code the indexes in your code because I mean, it changes, right? So the first node can be 4, sometimes it can be 5 another time, it could be 2, okay, in a third time. So it depends.
Interesting.
Okay.
Yep.
So I'm just trying to like say this, okay? If you look at identifiers of data definitions, okay, there's no easy way to handle multiple nodes, okay, and multiple fields, okay, so that you can, like, for example, use a for loop to loop through everything, okay. That's why, okay, that's precisely the reason why I introduced the notion of fully qualified identifiers, okay. Now, let us start with fully qualified identifiers of a data definition first, okay? So let me submit this, and I will pick something more complicated, and let's see something like more interesting, okay? Where can I find something more interesting? Okay, let's see this one. Okay, this one is better. So let us write some simple code and execute the code, and then we will look at fully qualified identifiers. So we have a data definition and cascade asset. And then we are talking about data definition. And let's first dump it to make sure we are reading it properly. Come on. Okay, so let's try that. So we are looking at the read dump of a data definition, okay? This part is empty because it's XML. So unless we look at the source, okay? So we don't see anything there. Now, let us dump the fully qualified identifiers, okay? Instead of dumping the object itself. So let us do something like this. So I want to use debug utility. and dump it. So DD get identifiers. Okay, this is what I mean, okay, by fully qualified identifiers, something like this, okay. So let us just pull them apart, okay, and then come on. Okay, so let's compare the XML and the fully qualified identifiers side by side.
So,
Okay.
Wing, question. I noticed that you use semicolons to separate different levels.
Mm-hmm.
Is there any particular reason that you didn't use slashes? Does it conflict with anything, or personal preference, or?
This is personal preference. I know, okay, in Cascade, Hannon Hill, okay, they use slashes. I use semicolon. It's just a personal choice. For one reason, okay, because I use like pattern matching in my code to deal with data definition, to deal with XML, to be able to like to insert data and so on and so forth, and the slashes get into the way.
Oh, okay, I can see that. Right,
Regular expressions.
Because regular expressions use slashes.
Exactly. That's why I avoid them.
Gotcha. That makes sense. I was just curious.
Okay, here, okay, we are looking at the data definition, and here we have the identifiers, okay? So if we look at the root elements, okay, well, root meaning except this one, okay? I'm talking about the root level fields, okay? So the first one, okay, this one will be corresponding to this one, okay, the first identifier. Now, everything will be the same except a group, okay? So this group is a root group, okay? Well, the identifier is group. But within, okay, we have like 3 text fields, and we see, okay, these 3 corresponding to those 3 text fields. Now, a fully qualified identifier is in fact, okay, something like this. It's just the XPath expression with all the slashes replaced by semicolons. Gotcha. As far as data definitions are concerned. So by doing this, we know, okay, we can identify a field easily by just following the path. Okay. So as far as data definition is concerned, okay, the set of fully qualified identifiers are just XPath expressions, starting from the top, okay, from the root, and then all the way down to the field, okay. That's just the path.
Makes sense.
Okay. So you can actually use this, okay, to retrieve, for example, a field. Okay, because they are all unique. Okay. Right. Now, what about DD blocks? Well, let us pull up some DD blocks. Okay. Well, let me just like pick the relationship, okay, corresponding to this block, this data definition, and pick a block. Okay. So this block uses this data definition. Okay. Further, let us just like create some instances. Okay. Well, some more instances. So we have like something like this. Okay. Because no data is required, so I can leave them empty. So we have something like this. Okay. Now let us like look at this instead. So instead of DD, okay, we are going to change it to DD block. And then we need to change this to data definition block. And of course, we need the ID. And we are dumping the identifiers, okay? Of course, I need to change DD to DD block. Now, this time we see something slightly different. Okay, let us look at the block again. We have a multiple first, okay, but we have like 2 instances of multiple first. And then we have a single. And then we have 2 instances of multiple second. Well, they correspond to these, okay? Now, pay attention to the semicolon 0 and the semicolon 1. When you work with data definition blocks, okay, instead of data definition, you start seeing semicolon some digit, okay, starting from 0. But again, if you understand XPath expressions, these are just positions. Okay, so multiple first, okay, followed by semicolon 0, means the first instance of a node, okay, with the identifier multiple first.
Wait.
And then we have, yep.
Sorry, I thought you couldn't have siblings with the same identifier. Are those different types?
Well, multiple first is a multiple field. Within this field, okay, you can have multiple instances of nodes. They all share the same identifier.
Right, but I thought you weren't allowed to have two fields called multiple first if they were in the same, if they were sibling.
This data definition, okay, let's go back to the data definition, okay. Data definition, let me just edit it.
If they're grouped, Eric, I think you're good.
Oh, really?
Yeah, because remember how we did the slideshow? Well, it's not grouped. Never mind then. Oh, wait, you do have a group.
Eric, multiple first, okay, there's only one here in this like root level.
Right.
Of course, okay, multiple first, okay, can appear elsewhere, okay, if it is in an inside group. But right here, okay, we only have one field with that ID. But
right.
it is multiple.
I see. You have two instances of that field. I see.
But one is wrapped inside of a group, and the other is not.
Group.
Okay.
Well,
okay.
actually no, because this is called group multiple first. The ID is actually different.
Right. Yeah, it's just when you save that, if you cancel out of that, I think it's showing two instances of
two instances, first. Yes.
There's a lot going on here.
Sorry.
No, it's not your fault. It's just there's a lot to look. You have a lot to look out for.
Right.
Okay. Where is my blog?
Right. So there they are.
Which one was I looking at? I forgot already. Okay, let me just pull this ID back in. Okay, this is the one I've been looking at. So when you have, like, oh, well, again, okay, these two are actually two different instances of the same field.
Gotcha.
And then we have a single instance of the second field, and then we have two instances of the third field. Okay, but again, if you look at the identifiers, okay, I'm talking about the FQIs now. Okay, they are unique in the sense that, okay, the first one has an index, okay, 0 attached to it. The second one has the index 1 attached to it. So they are still unique, okay, even when we look at like siblings. Well, siblings of the same type, of the same. So when you look at those identifiers, they are always unique.
Right. Gotcha.
Okay. That implies, okay, when you work with FQIs, you can actually hard code them in your code because they never change. Does it make sense?
Can't the user like delete one of them, one of the multiple fields?
Sure. For example, if you hard code this, okay, into your code, okay, then you need to check whether this node exists. If it doesn't, don't do anything. If it does, go ahead and do something.
Gotcha.
Of course, you need to do that.
Okay.
But I'm just saying, this node must always be there.
Gotcha.
Well, this is another point I want to bring up, okay? Within a blog or within a page, okay, the first node of any multiple field must exist. You cannot have like no instantiation of a certain field, okay? You cannot do that. There must be at least one. So meaning, okay, whatever, okay, ended by 0 must exist for a field.
Even if it's blank.
Say that again.
Even if it's blank. right?
Even if it's blank, meaning it contains no data, but the node is there. I'm saying this, okay? Well, you keep deleting, okay? For example, you delete this one, you delete this one, you delete this one, but you cannot delete this one. This one must be there.
Right.
So
Okay.
there must be at least, okay, one instance, okay, of a certain field, a multiple field. So whenever you talk about a multiple field, the identifier ending with the 0 must exist.
Right.
Okay, so this is a very important observation. Okay, when you work with multiple fields, okay, you can safely assume, okay, the first node is always there because you cannot delete the first node.
Right.
Okay, and my library ensures that, okay, when you, for example, when you like start deleting things, okay, the first node is never deletable. I don't allow that. Okay. Now, let's say we are working with something like this, okay? Now, a moment ago I told you, okay, you can actually hard code, for example, these IDs, okay, in your code. But actually, there's an easier way. How do we, like, for example, loop through all these nodes? Well, remember, we don't know how many instances, okay, there are in a block. For example, you can have, like, I don't know, because you can set an upper limit, but if there are no upper limits, you can have like as many as you want to in a block. So you can have 6, you can have 10, you can have 1,000 if you want to. Now, how do we work with, okay, a block like this, okay, without knowing how many instances, okay, of a certain field there are, okay, in a block? Well, I provide you many different like methods, okay, to work with nodes. So there is one method, very like a simple method, okay. Well, that will return the number of siblings of a field. So if we like look at the API of my library, so let me just pull it up. So let us look at data definition blocks and get number of siblings. Okay, so we are looking at a method called get number of siblings, and it will tell you, okay, how many instances there are in the same set. Now, as I told you before a moment ago, okay, you have to give me the identifier, okay, to like, okay, what sibling are you talking about, okay? So this identifier must be the identifier, okay, the FQI of the first node, because the first node is always there. So I require you to tell me, okay, when you talk about siblings, you need to give me like the ID of the first node so that I can give you the number of siblings of this first node. Now, there's a twist, okay? Actually, the number includes this first node, okay? So if we go back here, if we look at something like this, okay? If you plug in, okay, group semicolon, and then group multiple second semicolon 0 into this method, it will return 4. Any questions about this?
That was unexpected. But can you just enter group semicolon group multiple second up to that point?
Nope. You have to give me the, well, of course the 0 part, okay, I don't use, but you have to give me the 0 to
Really?
make sure, okay, which one you're talking about.
Oh, okay.
So when you work with multiple fields, okay, you always work with the FQI of the first node of a multiple field. You always do that.
Good to know.
Okay. Now, how do we loop through it? Loop through all these FQIs. Well, it's very simple. You have, okay, the number of siblings. Then you start with this part, okay, all the way to the semicolon, excluding the 0. Then you just like loop through everything from 0 up to the number -1. Let's say the number here is 4. So we start from 0, we count all the way to 3. Then you loop through every instance of this set.
What do you mean by -1? Did you
No,
say?
I didn't say -1. I'm saying you use this part, okay? And then you like attach 0 to it, you attach 1 to it, you attach 2 to it, all the way up to the number -1.
Oh, I gotcha.
Number -1 meaning because the last index is the number -1.
Sure. Okay.
Okay, that's how you loop through everything. You can have actually, okay, loop within loops, okay, so nested loops, okay. You can have, okay, multiple groups containing multiple fields inside. Well, for the group, you need to like find out, okay, how many groups there are. And for each group, you have to find out how many nodes there are, okay, within this group. Then you can like start with like I and J and K and L and M and so on and so forth. And then you loop through everything.
Yeah, one of my
You can
biggest
do something
peeves
like
about
that.
programming.
What?
One of my biggest peeves about programming is starting with 0. End with 0.
I don't know. But that's the trick, okay? You can play when
Yeah.
you are dealing with FQI. So you can actually like loop through everything within a block if you want to.
Yeah. Yeah, Chris, I hear you. A lot of times it's a matter of trial and error, depending on the language too.
Yeah, it is. It's just you have to do so much footwork just to adjust for that one offset, you know.
Yeah. Right.
Just put it at the end, and you don't have to worry about it. It's still 10.
Yeah. It's not intuitive.
Yeah.
I agree.
Well, you have to get used to it if you're a programmer. I mean, always like 0 days.
Yeah, that's the unfortunate part.
Except when you are dealing with XSLT.
Right. There is something in JavaScript I know that where they ignore the 0 and then they start with 1.
Okay. Well, you need to set the base. Yeah.
Yeah, but they don't. I think they're not real programmers.
It's a bit unfair.
Okay.
Okay. Let us just like go through some of the methods, okay, quickly, so that you know like how to deal with nodes, okay. For example, I'm looking at the API of ddblock, okay. So let me just like highlight this one, and then let's talk about it. Append, you can actually like write code to like add one node, okay, to a certain instance, okay. So when you call add sibling, you need to supply me the ID, okay, the FQI of the first node. Then I will append 1, okay, to the end, okay. So basically, we can do something like this. Let us try this, okay. I'm looking at the block, so let me comment out this line. And I want to add 1 to the end, okay. So let us do ddblock and then append sibling. So, and I need to fit in, okay, the identifier of the first node, okay, always the first node. So I'm appending this, okay, to this. And let me dump it again at the end, just to make sure we see what we want to see. So let's try it. Oh, this time we have 6. If I run the program again, I want to see 7. And if I run the program again, I want to see 8, and so on. Okay?
That's kind of cool.
Okay, let us like move on. I will come back to copy data too, okay, later. Now, this is actually interesting. Create n instances for multiple field. Well, you can actually say, okay, how many siblings I want all together, including the first node, okay? So you can actually specify, I want 1,000 nodes, okay, given the first FQI. Well, for example, you are copying data from one block to another block, okay, let's say. And then you know, okay, by calling number of siblings, okay, you know how many instances there are in the first block. You want to create enough and exactly the same amount of nodes, okay, in the target block so that you can copy data from one block to another block. Well, you need to say, okay, how many instances you want. By calling this method, you can create exactly that many in the target. Does it make sense?
Yeah. Now, does it assign it a value for you too?
Well, no. It just like creates enough. Well, actually, underlyingly, okay, underlyingly, it will just copy the last node and just like keep copying. So if the last node has data, you will see all data inside. But I assume when you like create enough nodes, you will start populating those nodes with real data. So you don't care about like what's inside.
Right.
So let us try this method, okay? So instead of a pen sibling, I can change, okay, this to this, okay? But let's say I want 10 of them, okay, exactly 10, okay? So after running this program, I want to see 9, okay, as the last index, okay? Now, if I want to say, okay, instead of 10, I want just 6 of them, okay? And the last index should be 5. Okay.
Huh.
So by doing this, okay, now we are building piece by piece, okay, but you know how to loop through them. You know how to like append one to them. You know how to create exactly n instances of them. Well, you can do a lot already.
So this not only this not only creates, but it'll delete instances to meet that number, that parameter.
It will delete, yes. If there's not enough, it will create. If there's more than enough, it will delete. Because that's what you want, okay? Create exactly n instances.
Gotcha.
Okay. So let's say we have 6 now, okay? So let us delete something, okay? So we can also like delete, okay, instead of like create number, like certain number, okay? So we can have, let me put up the, we can have remove, remove last sibling, okay? So we can have something like this. If I like put the code there. Now, I just want to point out one thing we have already seen again and again, okay? You always work with the FQI of the first node, okay? So let us just try this, okay? I'm like removing the last one, so 5 should be gone when I'm done. If I do that again, 4 should be gone. If I do that again, okay, 3 should be gone. If I do that again, 2 should be gone. And one more time, 1 should be gone. Now, what happened if I run the program again now?
Nothing, right?
It'll hold on to it.
Yeah. Or when you get an error.
Throw an exception.
Oh.
Because you're trying to delete the last one.
Shouldn't allow it.
Okay.
Like you said, it always has to be there, right?
Yeah, it must be there. So watch out for this, okay? It can throw an exception. If you try to delete something, that is the only instance of a multiple field. But normally, okay, you pay attention to the first one, okay? Any questions about this part?
No.
Okay. Now, about nodes, okay? I'm talking about 2 instances of the same field, okay? Nodes are defined by position. So let's say we are talking about the first node and the second node. We don't care about like what data, okay, is like stored in these nodes. So it won't make sense to talk about swapping 2 nodes. But it does make sense to talk about swapping the data. Am I making sense here?
Yes.
Okay, one more time. Nodes are defined by positions. So it won't make sense to talk about swapping nodes. The first node is always the first node. The second node is always the second node. But you can swap the data stored in these 2 nodes.
Gotcha. That makes sense.
Okay.
You can't move the nodes, but you can move the content in the node.
Exactly, exactly. Now, let's say, okay, we have, well, let me just like insert a few more nodes, okay, because I don't have enough nodes to work with. Okay, let's say we have 6. Okay, let me just execute this, okay, to make sure we have 6. And well, why don't we do it in the back end so we can insert some data as well. So right now I only have 1. So let us like put in more data, okay? And I just want to put in some data, oops, first, and second, and third, and fourth, okay? So we have something like this. Now, I don't want to do this anymore. So let's just like dump the identifier. So we have like 0, 1, 2, 3, okay? So let's try that. So we have 0, 1, 2, 3, okay, because we have 4 instances. Now, if we look at the data, okay, we store like first, second, third, and fourth in these 4 instances in this order. Now, what if I want to move, okay, fourth, okay, up, okay? For example, we want to swap third and fourth. Well, eventually, we want to move fourth up to the top, okay? Let's say you can do that. You can use a for loop to do that, okay? But right now, let us do something simple. We want to swap these 2, okay? So fourth will appear in the third node, and third will appear in the fourth node. That's what we want.
Okay. Yep.
So we have, okay, a method called swap data. And you need to give me 2 identifiers, okay, 2 FQIs, so that I know, okay, what swap with what. Okay, so we are swapping these 2. Okay, so let us like change the code. So let us just like start something new. Okay, I don't want to mess up the old code. So dd block, and then we are swapping data. So the first one is this one, and then the second one is this one. Come on. I'm not sure whether I should call edit swap data. I'm not sure. I probably need to. Because this is not a change of container, okay? So let me just call edit on the safe side. Okay, so let us execute the code. And let us check the result. Okay, so they're swapped. So let's say if you want to like do something like this, okay? For example, you want to move the fourth, okay, all the way to the top. You have to use a loop, okay, to move it like between like third and fourth, between third and second, and then between second and first to move it up. Okay. But if you want to, you can also use one single like method call. Okay, well, swap the first and the last. Okay, so we can do something like this if you want to. So we are swapping third and first. Okay, when we do this. So this will store first, and this now stores, okay, third. So third will be on the top if we do this. Okay, so let's try that. Where is, oh, no, here. So third is on the top, and first is at the very end. So depending on what you want to do, okay, sometimes you can like swap the data of 2 adjacent nodes, the 2 adjacent siblings, or you can like basically, okay, give me the index of the first one you want to like swap, and then you give me the index of the second one. However, like far they are like separated, I don't care. You just like give me 2 identifiers, okay? Then I'll swap the data. Okay. Any questions?
It's kind of neat.
So let me recap, okay? When you look at a data definition block, you can insert instances, you can remove instances, you can reorder the data, you can make sure, okay, I want to have like n instances of certain field. Well, this already like is a lot, okay? You can actually like create enough containers, and then you can move data around, okay, within the same block, of course, okay. We haven't come to like mapping data yet, okay, but within the same block, you can move things around already. Okay, any questions up to this point?
No, this is pretty cool.
Okay, there are so many different like methods, okay, allowing you to like manipulate nodes, okay. So just like check them out. For example, you can like swap, you can delete, you can insert, you can. Let me just scan through them quickly.
Is there one? Is there one that allows you to modify the attributes of a node, such as whether it's required or not?
You are talking about changing the data definition. You're not changing. You're not changing a node.
Oh.
Right?
Yeah, I guess now that I think about it, yes.
Yeah, you are modifying the data definition.
Okay, so that's different.
Yep, that's different. Okay, now, well, why don't I just like go into this topic and see how far we want to push, okay? When you define a data definition, no, data definition. When we define a data definition, okay, we can have actually 15 options. These 15, okay, I'm talking about these 15. So you can have a group, you can have a text box, you can have a text area, you can have a WYSIWYG, checkbox, and then this is a drop down allowing you to pick only one item from the drop down. Radio buttons, and then this is called multi-selector, allowing you to select more than one item. And then you have the calendar, and then you have the date time. You have a page chooser, a file chooser, a block chooser, a sibling chooser, and a linkable chooser. So when you work with data definitions and data definition blocks and pages, you need to deal with these 15 types of fields. And each one is slightly different than the next. Okay, so when you work with, for example, a DD block, okay, you need to, for example, look through everything. But then you still need to find out, okay, what node am I dealing with? Okay, am I dealing with a group? Am I dealing with a chooser? Am I dealing with a text area? And so on. So in my library, I just added a whole bunch, okay, just in the last few days, starting here. So first, okay, when you look at the data definition and when you look at those nodes, okay, there are three big groups, okay. Well, the first one is called group, very simple. So a group can contain other children. The second group, okay, are called text. They start from here. Oh, let me see. They start from, come on, I cannot highlight them. Okay, it ends here. So I'm saying this, okay, if you look at field types or node types, okay, there are three big groups. The first is called group. The second one is called text. So including text boxes, text areas, check boxes, radio buttons, drop downs, multi-selectors, and so on, calendars and date time. The third group are called asset. Well, including page, file, block, symlink, and linkable. Okay, so we're talking about three big groups here. So the first method is called isAsset. It will return true or false, depending on whether it's a chooser. If it is a chooser, it will return true. Otherwise, it will return false. Okay, and then the second one is called isGroup or isGroup node. Okay, depending on whether you want to use aliases. isGroup will return true only when the field or when the node is a group. The last one is text or is text node. Okay, so we have like three big families of like fields or nodes. Okay, group, text, and asset. So you can use these methods, okay, to test, okay, what fields or what nodes you are dealing with, okay, as far as like the first layer is concerned. So you need to like deal with like the first layer. If it is a group, you do something. If it's a text, you do something. If it's an asset, you do something else. Once you get past the first layer and then you go to the second layer, if it is text, then what kind of text are we dealing with? Is it a checkbox, or is it a text box, or is it a text field? I mean text area, or is it a date time, or is it a calendar? Something like that. So you can like determine what kind of like what type of field you're talking about. Is it a group? Is it a text? Or is it an asset? And then if it is a text, then you can further test. Okay, is it a date time? Is it a drop down, or what? And then you can do something correspondingly.
So
okay,
that's a pretty big if statement.
Yeah, I know. Well, let me show you a program. Okay, on GitHub. So examples and recipes, data definition blocks, and then what with different types of nodes. So here is a program showing you how to deal with like different types of nodes, those 15 of them. Now, if you look at the code, okay, first we have one block to deal with a group, okay. It's simple, okay. If it's a group, just a group, okay. But if it's text, okay, then we can like go further and drill down, okay. Are we dealing with a checkbox? Are we dealing with a radio button? Are we dealing with a date time? Whatever. And then the third part, okay, the third part is asset. So are we dealing with what kind of choosers are we dealing with, okay? Is it a page chooser, block chooser, or symlink chooser? So you can see, okay, the code is organized in 3 big parts, okay? If, else if, and else. And within, for example, text, okay, you can further, okay, like, okay, look inside what kind of text nodes you are dealing with. And then you do something correspondingly.
That makes sense.
Okay. Now, before I forget, so far, whatever we have been looking at, okay, starting from data definition, and then to fields and nodes and like append sibling and so on and so forth, everything we saw are applicable to both DD blocks and pages. So whatever we are looking at right now is applicable to pages as well. Okay, I assume that much.
That's cool.
So if you understand this part, you know how to deal with them on pages as well.
Okay.
So when you look at a page, okay, you have to deal with, okay, the default, and then you have like, well, nodes inside. You want to create exactly n instances of a multiple node. You want to deal with a date time. You want to deal with calendar. Exactly the same code.
Now, obviously it would be different though, because on line 14 you'd be passing a.
Of course, when you retrieve the asset itself, it must be different. I'm just saying,
Well,
from this point on, most likely the code will be identical.
Well, I guess what I'm just verifying is that can you access all of these methods directly from a page asset, just like a block, a data definition block. Okay.
Yes. Well, let us just like pull up pages as well, and you can actually compare them. Of course, okay. There are subtle differences here and there, okay. But if you look at the big picture, they are almost identical. Of course, well, there are methods, okay, specific to pages, and there are methods specific to blocks, okay. But they share a huge set of like common methods. For example, we're looking at pages right now, okay. So starting from here, okay, we have append sibling, we have create instances for multiple field, we have the is methods, okay. So we have is asset node, is block chooser, is calendar, and so on and so forth. They are common in these 2 classes, okay, I'm saying.
Gotcha.
Because you have all these methods from structured data. These are just percolated methods.
Is that class inherited from something?
No,
No?
because well, page and data definition block don't
Gotcha.
share a common parent that's unique to them to these two types.
Okay.
Because I mean, the parent of a page is actually a folder, right?
Hmm.
And folder can contain a lot of many different things. So I cannot really like deal with, okay, like we're creating another class, okay, for page and data definition block.
Right.
I can, but I don't see the point, okay?
Yeah.
So I duplicate a lot of methods, true. Okay, and one more point, okay, we brought this point up before, okay, method percolation. Something like this, okay, is calendar. Is actually percolated from the structured data object contained inside a DD block or a page, because they both have structured data. Okay.
Okay.
Okay. Let us move on. Okay. I just want to briefly like talk about these. Okay. Well, just let's us just like highlight let's say one or two things. Okay. For example, if you work with is calendar or well, a calendar node or a datetime node, okay, you have to pay special attention to the data you want to feed in when you set data. For example, let me just put up example code. Let's see, multiple nooks. Let me just like finish this, and then we can go over this. Okay, the list of like programs. Multiple nooks. Number of siblings. Do I have an example? Probably not. Test code. Okay, test code. Test code. DD block. Data definition block. Multiple field. Multiple text. So this example, okay, under PHP Cascade WSNS examples, and then DD block multiple fields. I showed you, okay, how to deal with, for example, a date time or a calendar. Okay, I just want to focus on these two. For example, date time. Where is it? Radio calendar. Okay, a calendar. Okay, when you work with a calendar, you have to like give me uh, a calendar a string. Okay, so that you can set the text of the calendar. But you have to observe, okay, the convention. We are talking about month, day, and year, and you have to do it that way. Okay, you cannot like, for example, give me the date first. You have to give me the month first. Okay, so the first one is the month, and then the second one must be the date. Okay, and then the last one is the year. Well, you have to like go by this convention. And there's also some restrictions like imposed on us by Cascade. For example, you can always do like 15 years in the remember exactly, okay? Maybe 15, maybe 25, I don't remember. But you can only like, deal with, okay, so many years before and so many years after today. If you do something too far in the past or too far in the future, Cascade won't do that. So if you do something like this, okay, December 3rd of like 1950, you cannot do that. It's too old.
Really?
Yep, try that. There's a restriction, okay? You can only do like so many years in the past and so many years in the future.
Okay.
And my library will check that. Okay, that's calendar. Date time. Date time. Let me just search. Date time. So date time must be set. This is not a good example. You need to like plug in like the day, I mean the calendar part, and then you need to give me like the hour, the minute, the second, the whole string, okay, to make this work. Unfortunately, I don't have an example here. I might be able to dig up some example elsewhere, okay? But I just want to like emphasize one thing. When you feed in, okay, a value for date time, you have to give me the date time value in the correct format. Otherwise, I'll reject it. Okay.
Okay.
Okay. I will stop here with respect to those 15 types of fields and nodes. Okay. Let us move on to the next major topic. Okay, phantom nodes. We've been talking about phantom nodes, okay, for a while now. So I want to like say something, well, to conclude this discussion on phantom nodes, okay. When you, I want to draw a distinction between two types of phantom nodes. I will also want to like bring up a third one, okay, a phantom value. Okay, and when you work with like web services, you have to watch out for all these three. Okay, phantom nodes first. I draw a distinction between type A and type B. Okay, well, Eric Gawker knows what I'm talking about because he dealt with at least one type of them frequently. Okay, when you create a data definition, something like this, okay, you can, okay, like create a data definition, and then you create blocks associated with this data definition, okay, and then put them in use for a while. Later on, you want to change the data definition by removing a field. I'm talking about removing one field from a data definition. If you do that, all the blocks, okay, associated with this data definition will have phantom nodes of type A. I'm saying this, okay? Let's say we have a text field here, okay, in the second one, okay? We put this data definition in use so that there are blocks, okay, associated with this definition. Okay, all the blocks this data definition used to have two types of like, well, two nodes, okay, or two types of nodes, okay. But you're removing one data definition field, okay, from the data definition. But in the database, okay, all those blocks still contain data with respect to the field you're removing. This is what I meant, okay, by phantom nodes of type A. If you look at a block, it contains data that is not licensed by the data definition. This is type A. Okay.
So is this referring to the data that sometimes developers hide in data definitions?
I don't know what you mean by hiding.
I think Eric, last time you mentioned that sometimes some Hen and Hill developers hide information on purpose in using phantom nodes.
Yes, Penny had mentioned that they will count on those phantom nodes existing when they're doing restructuring of the data definition.
Yeah, okay.
So, yeah,
So,
she had mentioned that to me once.
So would those be type A?
Yep, that's
Technically, yeah.
Okay.
So you have extra data that is not licensed. Not licensed by the corresponding data definition. So they are illegal, basically.
Right.
Okay, that's type A. Type B is different, okay? Type B is this. Again, you have a data definition in use, okay, associated with blocks. But somewhere, okay, along the line, okay, you add a new field. For example, a third field, okay, in this data definition. But then all the blocks associated with this data definition will have one node missing. Because it's new, okay, it's brand new. So if you look at the block, this node does not exist. You can try that, okay? You start with a data definition, and then you associate with a block. You read it with web services, and then you insert a new field in the data definition. You read the block again. The block won't know the existence of the new field. And there's no way to insert anything into this instance, okay? Because the instance does not exist.
But if you then go to that data definition block or that page and you hit submit, then
You
it'll,
manually do that, okay? You have to
yeah.
manually do that, okay? And you
Okay.
have to insert some data into that field. It
Okay.
cannot be empty,
I see what you mean.
okay? So this is called phantom nodes of type B. It's not illegal. Rather, it's just simply missing.
Gotcha.
It should be there, but it's not.
Wang, there must be data. Does that include, say, an empty string?
Empty string doesn't count.
Because that's
Empty
usually
string.
how I pad to prevent it from not having, how do you say it? To make sure the node exists, I'll just send an empty string, essentially.
Oh, you are sending an empty string to it. I'm saying you don't do anything to it. By default, it's just, well, actually, when you read it, it's actually like, it doesn't exist, okay? But if you force me, it's just now instead of the empty string. Okay? Now, I want to emphasize this, okay? If you insert a new field into a data definition, there's no easy way, okay? Well, if you don't use my library, okay? There's no easy way to force the reappearance of the missing node, okay? Because it's not there. Now, in my library, I have a method, okay, to allow you to force them to reappear, okay? Actually, this is page. It doesn't matter, okay? Page has the method. So I have a method called has phantom nodes, okay? This method deals with phantom nodes of type B, not type A, okay? Now, do you have any questions about this method?
Is that like a Boolean? Well, actually, I guess it returns a Boolean.
Yep.
So does that just tell you whether you have any phantom nodes of type B, but not add them?
Well, I provide you a method to do that, okay? It's called map data. Map data here.
Wing, you think of everything.
I was thinking the same thing. It's like he knew I was going to ask that question.
Like, let's try to stump him.
But remember, you should call the checking method first, because if you call map data directly, okay, you're just mapping something to itself, okay. If there are no phantom nodes, of course you can do that, okay. It won't hurt, but it will waste you some time, basically.
Yeah.
Okay. So you should call has phantom nodes, okay, first. If it's true, then call map data. Then it will fix everything. Of type B.
Wing,
Yep.
the description of that method, map data, is that it removes all phantom nodes of type B. But you defined a phantom node of type B as the absence of a node.
So isn't it really, yes, add nodes?
Yeah, true. Yeah, you're right.
Okay.
Basically, it forces them to reappear. Yes. I see your point.
Okay.
So basically, well, in one sense, it's removing phantom nodes, but in another sense, it's like forcing all the phantom nodes to become real nodes.
Right.
Fair enough. Just clarifying. I just wanted to clarify.
There had to be a reason.
Good question.
Yes, thank you. I keep saying remove phantom nodes, but in this case, you're forcing them to adopt their real identity, basically.
Right.
I keep saying B. What about A?
What about it?
Well, how to fix them? For example, there are easy ways. Okay, I provide you easy ways to fix phantom nodes of type B. Because first you can call, okay, whether there are any phantom nodes of type B. If there are, you call map data. You're done.
Yeah, but you may not want to fix
You may
phantom
not.
nodes of type A.
I leave it to you. You decide.
Because then, you'll piss Penny off. We don't want that. Right.
Okay, but remember that's phantom node type A, not B.
Right.
Okay, back to A. How do we fix them when we deal with like phantom nodes of type A?
I
Okay.
revert to my previous statement. We don't want to piss Penny off.
Okay. Question. How do you identify phantom nodes of type A in the first place? You saw them before. You will see an exception. Remember? Field
Yes.
not found.
Okay.
Do you remember?
You mean
Let's say
today?
if you have a block which contains a phantom node of type A, you try to load the block, you will see an exception. A field is not found.
Right.
That's how you identify phantom node of type A. Namely, my library doesn't load a page or a block containing phantom nodes of type A.
Oh.
Do you follow my claim? My library doesn't deal with them.
Okay.
Okay? Does it mean they are not fixable?
Wait, Eric. I think Eric has a question.
No,
Okay.
no, I'm thinking of the don't piss Penny off category here. Um, because I could see an instance where you are, for instance, restructuring your data, and you want to be able to read a phantom node in order to write it back to now an existing field
Okay.
in your restructure.
Sure.
So if you don't allow the ability to read a page that has a phantom node, then that would be impossible to do. And it might piss. And it might
Yes.
piss a Penny off.
Yes and no. Okay. Okay, let me just give you more information. I'm saying this. If you use my page class or if you use my data definition block class to load either a block or a page with phantom nodes of type A, I will give up. I won't do anything. I'll throw an exception instead.
But you could read an asset, right? If I recall, there's the other way to read a page.
Yes.
Okay.
They're not documented, okay, but they are in my library. So let me show you, okay, what I meant.
Secret handshake.
Phantom methods, phantom classes.
Okay. Let us look at page, okay? So I have a page class, but there's also a page phantom class. Okay, a class called page phantom. And alongside with data definition block, I also have a data definition block phantom class. These two phantom classes, okay, allow you to load something with phantom nodes of type A. Okay, that's how you load something, and then deal with it later. Okay.
So you'd look for the exception. If you get an
Yep.
exception, you have a phantom node,
Then
and
you need
therefore
to
you call.
Yep. So let me show you some code, okay, with those two classes. So handling phantom nodes, where are they? Let's see. Tree traversal. Phantom nodes of type A, phantom nodes of type B, and let's try this one. Here I'm just reporting, okay, so I'm not fixing anything. I'm catching the exception, okay, so that I know, okay, there's a phantom node inside, no such field exception, and I'm reporting, okay, so I can just use a try block, and then in the catch block I just capture the path of the block or page or whatever and report them. So this one is easy. Do I have anything to fix them? There must be, but I don't remember where. Probably not in tree traversal. Let's see. Recipes. Pages. Let's see. Do I have any phantom notes? I don't remember anymore. Where did I put them? Data definition block. Nope. I've been working on this lately. Phantom, creating assets, data definition. I don't remember where I put them. I'll dig them up, okay? They are somewhere here, but I don't remember where. Mapping data. Oh, they're here. Okay. Type B is easy, okay? Type B, you call map data. Okay. Well, I'm not testing here. Okay. So I'm doing something maybe unnecessary. Okay. Because I don't care. Okay. Just like, okay, do it. If there are nodes, if there are no phantom nodes of type B, do it anyway. Okay. Basically, that's what the code does. But type A is different. Okay. So let me just run through the code. Okay, line by line. First, I have the page ID, and I know, okay, there are phantoms inside. So I use the page phantom class to load it instead of page class, okay? But remember, you cannot use cascade get asset. You have to do it like this, okay? You're creating an object by calling the constructor. Because
Okay.
cascade cannot deal with phantom nodes, okay? Now, this line, okay, we are retrieving the data definition corresponding to the page. Okay? And then we create a structured data object through the data definition object.
Okay.
Okay? And then we retrieve, okay, the structured data object from the phantom page. So we have two structured data objects, one healthy, one with some. Okay?
Hey, Wayne,
Now
could you repeat that? I didn't hear
okay, we have two structured data objects. One created directly from the data definition, meaning everything is okay, everything is licensed. And then we have another structured data object containing phantom nodes of type A.
Did you go out and play in the rain yesterday?
Okay, now we are mapping data from the one with phantom nodes to the healthy one. Okay, this is about data mapping, but it's done in this method. Okay, once this method is executed, the healthy SD will store all the legit data and removing all the phantom nodes. Okay, now we have the healthy SD, we just call set structured data, okay, by plugging in the healthy one. Back to the page.
So that fixes it? That,
yep.
Or that replaces?
You are replacing the structured data object.
Gotcha.
Everything is hidden in this method, okay? In this method, I have to loop through all the nodes and so on and so forth, determine which one is the healthy one, which one is the sick one, and I map all the data, okay, from the phantom SD to the healthy SD, keeping all the relevant valid data and discarding all the phantom data.
I don't think Penny's going to appreciate you referring to her stuff as unhealthy.
But if you want to deal with whatever data, okay, that is not licensed, okay, let me put it this way, not licensed, okay, unlicensed data. You're still here.
Not unhealthy.
Misguided.
So all the data is still in phantom SD if you want to. Okay? But you decide, okay, what to do with it. My method, okay, will ignore them.
And just to be clear, remove phantom nodes. That method removes any nodes that don't match the data definition, basically.
Exactly. So it deals with type A. It doesn't deal with type B.
Right.
Certainty. That's what you want. Certainty. Sorry. English major's kicking in.
Okay, you need similar code, okay, to deal with blocks. But if you compare them line by line, okay, they are practically identical.
Yeah.
Okay, so this is the method I provide you, okay, to use to map data. But this is just like for phantom nodes. Later on, we still need to pick up the topic of like mapping data. Okay, for example, if you want to like switch content type, you want to use a new data definition, what then? I cannot deal with that. Okay. So just like one more time, okay, you can use this class or this class, okay, phantom, to load something with phantom nodes of type A, and then you deal with them, okay, working with two structured data objects side by side, and you basically like map all the healthy data over.
Okay.
Okay, any questions so far?
No, I think that's pretty cool. It seems pretty easy considering.
Yeah, I've been providing you like all the methods you need. You just need to know like when to call what.
Right. Right.
Okay. Let me touch upon the topic data mapping briefly. Okay, I will revisit this topic later on. Okay, when we look at pages. But let's say we have two data definitions. Okay, let's say we have two completely different data definitions. Okay, associated with blocks. And we try to migrate, okay, well, let's say, okay, we have like data definition, okay, DDA and DDB, okay, so data definition A and data definition B, okay, A is old, B is new. And then right now, A is associated with a whole bunch of blocks, and we want to migrate everything, okay, from A to B. Okay, that's the requirement. Further, okay, let us assume, okay, when you like create those two DDs, okay, they don't like map tidily. For example, you have like some identifiers in A but not in B, and some new identifiers in B, and probably they are regrouped, things moved around, things like that. This can be a nightmare, okay? Because I mean, you were not careful, okay, when you like design data definitions, okay? So you have something totally different, okay, from A to B. Let's say, okay, the worst scenario. Now, what do we do if we run into a situation like this? Well, we have FQIs. Okay, so let's say from data DDA, okay, we have a set of possible FQIs, and then with DDB, okay, we have another set of possible FQIs. We just need to map one to the other. What do I mean is this. Let's say we are dealing with a multiple field here, okay? So we have like group, semicolon, group, multiple, second, and then 0, 1, 2, 3. Let's say, okay, in the new data definition, we don't call it group. Instead, we call them slide, for example, okay? Or slides, okay, plural, slides. So we have something like this, okay? So we have this ID, okay, maps into something like this, okay? So I'm just like writing pseudocode here, okay? So we have something like this, map into something like this. We can have slides as the group name, and then we have like images, okay, for example, okay, 0. We can have something like this, okay. This is what I call data mapping. So you can have like as many as you want, okay. So you can have like this, and then you can have the first one, the maps, well, 0 maps to 0, and then 1 maps to 1. But remember, you don't have to lay out everything like this, okay? You can call like get number of siblings, so you know, okay, how many there are in A, and then you just need to create exactly like that many instances, okay, in B, and then you map, okay, whatever with group semicolon up to this point to whatever on the other side.
So
Okay.
this is how you would, for example, if you wanted to rename
Yeah, if you are
identifier
renaming things,
in a data definition,
mm-hmm.
this is one solution.
Yep, this is probably the only solution you have. Now I'm still assuming something tidy, okay? But let's say if you have really something untidy, okay? I don't know, something like this, okay? So you have actually like two groups, okay, wrapping up the image. I don't know why, but still you can still do a map, okay, a rough map, okay, from this to that. Well, as long as you give me a very like good map, okay, like this, then in your code, okay, basically you are saying from the key, okay, you get the value, you plug it into the value part. Of course, you need to like deal with each node, okay, by like, for example, checking whether it's a chooser, whether it's a text, whether it's a calendar or whatever. You need to give me like well, you need to write code, okay, like this. You do a very detailed map, okay, from the source to the target. You take care of all the type differences. You take care of like all the paths carefully so that the map is exhaustive. Then you can use this as an array. You just basically look through the array, okay? When you see this ID, grab the image and plug it into the corresponding chooser. You grab the text and throw it into the WYSIWYG, whatever.
Cool.
Okay. This is what I meant, okay, by saying like data mapping. And I cannot deal with that because, okay, this includes, okay, proprietary data and your business logic. I have no way to anticipate, okay, how to map data. So you're on your own as far as this part is concerned. But it's still doable. It's still doable.
Sure.
Okay, let me like show you another program, okay, dealing with like data map. Create phantom nodes. Wait. Where are they? I am, let's see, mapping data. I should put more examples here, but let's go to traversal. Tree traversal. Where are they? Tree traversal. For example, non-responsive to the RW1. Here I show you a real program I use, okay, to like convert non-responsive sites to responsive sites. Let me find the right thing. Here. I'm dealing with data mapping here. Okay. Although when I like create data definitions, okay, from one to another, I try to like keep basically like using the same data definition, okay, if I can. Of course, okay, from non-responsive to responsive, that's impossible, okay. I need to deal with like bootstraps and like call X3 and so on and so forth. But I try to maintain everything else the same so that when I map something to something, I don't have to like do a lot of like crazy mapping. But still, okay, there are fields, okay, there has no correspondence like on the other part, okay. So you basically need to like say start from the source. How do I map the source into the target? If it's like missing in the target, maybe I can discard it. But if it's like has a counterpart in the target, then basically like from this ID map to that ID. You may need to like juggle with, for example, okay, I'm making things up. You may need to like turn a date time into a text field. I don't know, okay. If you run into problems like these, you need to come up with a solution, okay. How to map like a date time into a text field. I don't know. You decide, but you can do that. Okay, by testing the first one and testing the second one and how to map them. Well,
Sure.
you design them. You know how to map them, okay? You should know. This is what I meant by data mapping. And it can be quite messy if you don't work carefully, okay, with those two, well, the new data definition. That's why, okay, I insist, okay, if you are like designing a new design and like a new implementation, work with your data definition carefully to make sure, okay, years from now, you don't make drastic changes. because it will like bring in a lot of problems. If you design them carefully right at the beginning, years from now, you don't need to do a lot of crazy mapping. Well, for one thing, you want to put everything into groups. Okay, that's for sure, so that you don't have a lot of like root elements. Okay, I want to stop here. Okay, for data definition about DT blocks. Okay, we have covered enough topics for you like to deal with.
Yeah, no, that.
Okay, I will stop the sharing. Questions?
No, none here.
Okay.
Try by example.
Try by example. Yeah.
Or doing
I
it
guess
rather.
I have a question. So why would you recommend not having a lot of
Always
root
phantom.
level siblings? I don't know. In obviously not having your framework, I found that the fewer groupings I have, the better when it comes to juggling a lot of the elements. Oh, we lost sound. We can't hear you.
Sorry.
There you
There you
go.
go.
Okay. Well, first, you can move groups around easily, right? Because FQIs are the same, even if you move them around. So you're changing the interface without changing the set of FQIs if you put them in groups. So you can reorganize those groups, move them around without changing fully qualified identifiers.
Hey guys, I got a bail. Thanks for waiting.
Okay.
Sorry.
That's the first reason, okay? Second thing is closely related to my implementation of like, well, macro invocation automatically. Well, I'm doing this, okay, in my like newest implementation. If you put things, okay, into groups, let's say, okay, just consider data definition blocks. If you put things into groups, okay, you can actually start from like the very top, okay, and then when you like look down from the top, you only see groups. You don't see any other like text fields and so on and so forth. So from a block, you go to a group, and then from the group you can go elsewhere, okay. But I'm saying this, from the block, I know I can actually calculate what macro to invoke to process a certain group. Okay, because you only have groups, okay, as like root elements. And actually, you can reuse the code if you have the entire group appearing elsewhere.
So you're thinking about it from a velocity macro point of view?
Yep. So I can have like a block, and then I can invoke a macro to process a group. This group can appear anywhere I want. I can invoke the same macro to process the same group appearing in any block associated with any data definition.
Okay.
Eric, could you repeat your question?
What are the advantages of reducing the number of root elements in a data definition by using groups, if that makes sense? Because sometimes when you're just dealing with the raw web services, groupings are definitely doable, but then there's more tricks that you have to jump through when you're dealing with a group. And so sometimes flattening the structure makes it easier for me to deal with, or has been easy for me to deal with under those circumstances. But if obviously, with the framework, you're working around those disadvantages, if you will. So I think that there are other advantages that would be good. All right, makes sense.
Well, another thing like brought up by Espana was you can have identical identifiers within groups. I mean, not within groups, across groups. I mean, so you can have like the same identifiers appearing in two separate groups. If you insist, okay, you want to have something like that.
Right. Yeah, and I've used that technique.
Any other questions?
when are we gonna do the next one?
Before the
You put in your
next time,
topics.
I would not really like talk about. I will pick up pages, but I will talk about, for example, how to do we talk about like how to map data. Okay, now, so that's basically done. So we also talk about so we'll focus on like how to work for example searching, how to like using regular expressions, using patterns, and so forth. But again, this applies to the data definition as well. And then we can pick up switching content type and switching data definition, switching and so on, switching everything practically.
Okay.
And we can wrap up everything.
Wing, I think your mic is echoing again, but I think I understood. Yeah, I'm just looking at my calendar to see quickly what the schedule is like. So a month from now is July 4th. Oh, obviously that's not going to work. Maybe July 11th.
July 11th. Okay with me.
I can set that up if it's okay with Eric, and just as a hold.
Well, we can set it up temporarily and change it later after.
Eric, you're muted. I was trying to read your lips, but
yeah, I know. Because I work from home on Mondays with doing daycare in part, I alternate weeks with my wife. I have on my calendar that that's not a day that my wife will be here, but that doesn't mean it's impossible. It means I'd have to make special arrangements.
Okay.
What about like 1 week later, the 18th, for example? Or all Mondays are out?
No. The 18th, I have on my calendar that she will be here. Means I should check with her first.
So how about we tentatively reserve the 18th, and then, I'm pretty flexible. I could do the 11th if that works better for you.
All right. Well, let's actually hold on a moment. My wife is actually here. I will check with her.
Cool.
Actually, I think it has something to do with Google Hangout because I mean,